Hey, what's up you guys? It's Ilarian Garbus with you. Today we'll do the credit default analysis of small loans on the Lending Club platform. Why do we need this? For example, Jeff Bezos wants to start lending money to people, and he needs us to predict the performance of a given loan or portfolio of loans. I'll show you the code and we'll go through it, and finally I'll give the link to this code and you can ask me questions, you can comment my code, and don't forget to push the like button, subscribe and crush the like button. Okay, let's do it together! I want to introduce the analysis of Jeff Bezos' task. So he wants to start lending money to people, needs us to predict the performance of a given loan or portfolio of loans, and build a dashboard as well. So I found the relevant database at kaggle.com. They've got all Lending Club loan data from 2007 to 2018. I'll do this analysis in Google Colab. So first of all, we need to upload the data. I would use NumPy for linear algebra and Pandas for data processing. So read CSV from the file that I uploaded. So here is the data frame head. So we've got different data on loan borrowers. We can describe the data, see the count, mean, and other parameters of the data. So we've got 158 entries. So as we uploaded the data, let's now visualize it and make little feature engineering. So we would transform the loan status into a binary variable where charged off equals 1 and fully paid equals 0. So it is our label. Let's see the distributions of different features in data. So we've got grades, and we see the distribution of grades, distribution of the employment length, and we see that we've got a lot of more than 10 years employed people. Let's see the connection between employment length and default rate, and we see that the people who are lower than 1 year got more default rate, and the people who are more than 10 years got a little low default rate. So we would use it in the feature engineering. Let's see the distribution of the interest rates. So we got different interest rates. The distribution of annual income, it's normalized. The most common reason for requesting a loan and the distribution of it. So it's for debt consolidation, credit card, home improvement, other different reasons for requesting a loan. Connection between grades and default rate is linear, and we see it on the plot. A connection between grades and interest rate is linear too. The distribution of loan term, we see a lot of 36 months terms of loan, and less 60 months term. So the connection between term and default rate, so we see that the people who got 60 months rate or term got a bigger default rate. So this is the distribution of home ownership feature value counts. We got a lot of people with mortgage, rent, and who own the house.
the property, the connection between home ownership feature and default rate, mortgage ownership and rent, and we see that the people who rent property got higher default rate. The distribution of FICO score. FICO is a data analytics company based in San Jose, focused on credit scoring. So it's like a credit score for loans. And the FICO score, we see the distribution of it. And the distribution finally is the distribution of installment. An installment loan is a type of agreement or contract involving a loan that is repaid over time with a set number of scheduled payments. Normally at least 2 payments are made towards the loan. And we see the distribution of installment. So let's describe the linear connection between default rate and interest rate. We would use linear regression, and after we would fit it between default rate and interest rate. We see the it's the linear connection between it, and we can the equation. We can define the coefficients in the equation of this linear connection. So it's a classification problem, and in our first approach in lending club analysis, I would use logistic regression. Then we can use different trees decisions, but at the start I would use the logistic regression, and I would train the logistic regression. So in our analysis we would reduce the data set to the following columns that are known to investors before the loan is funded. So we got different 21 column that investors that Jeff Bezos know before the loan is funded. And we would drop NA, and the shape would be 126,000. Oh, it's not 100. It's 1 million. 200,000, 65 to 6,500,000, and 21 feature. So we map the grades, get dummies for categorical features, drop all dummy variables which contain not at least 1% of ones. So after that we can see how the data would looks like. So we see different dummy variables and numeric features. So now we can split our data from the label and train from the test. We would use test size 0.2 and preprocess the data with a minimum maximum scala. Would take from the linear model logistic regression and would use pipeline. So our scala is minimum maximum scala. Our model is logistic regression with L1 penalty. L1 penalty because we want to know which features matter, and we will see it next. So we're using the pipeline. We feed the model, and after we feed the model, finally we got accuracy score of 80%. We can plot the ROC-AUC curve and see the ROC-AUC curve 71, and finally see the testing score with linear regression. It would be 80%. And after we trained the logistic regression, we can see which features are most important, and we will do this with these 2 lines of code, and we can see the dependencies of features in our final result. So here it is. It's a brief analysis for Jeff Bezos of a lending club data. So feel free to ask me different questions on this analysis, and feel free to give me more tasks or more ideas for this analysis. And if you want me to make this analysis in the new approach, so I can do this. Thank you so much for your time, and hope to see you soon.